Hello, this is Anthony Precella. Today we're going to continue working on the review sheet for my face-to-face college algebra classes first test. We've already done problems 1 through 19, so we had some imaginary numbers and quadratic equations, and then we had some equations with the fractions in it, about 12 and 13 and 14, some radicals, cube roots. Then we started reviewing cut point method, solving inequalities, and we're up to number 20 right now. So let me write it down and get started. It's problem number 20. X over x plus 1 is greater than or equal to 2. X over x plus 1 is greater than or equal to 2. Well, we had a sequence of steps. I refer to it as a recipe for solving inequalities, where we find the solution cut points, the denominator cut points, draw the number line, label those cut points, test an interval. The shaded intervals will be the true intervals. And your final answer, express it with interval notation for the shaded intervals. And so, starting off with the solution cut points. So to find the solution cut points, we put a equal in place of that inequality symbol. So we have x over x plus 1 equals 2. I think I'm just going to write that as 2 over 1 and cross multiply. So what would we have? We'd have a 2x plus 2 equals, is that just going to be a 1x or x? Now, this is a linear equation because there's no x squared in it. So just isolate the x. We need to put both of the x's on one side, and so I think I'm going to do this. I'm going to move this 1x over to the left, and this 2, I'll subtract from both sides and move it over to the right. So we have 2x minus 1x, that would be x, and subtracting 2, is that going to be a negative 2? And at the cut points, you always have either open or closed circles. This one's going to be, you look up here for the solution cut points to decide, and it's a closed circle because there's an equal sign. If there hadn't been an equal sign, it would be an open circle. Remember how you can remember the one that takes more ink here uses more ink on the circles. The greater than equal to takes more ink to write, so use the closed circle, which uses more ink. So somehow you got to remember it. That's how a student told me that she did it, and I thought, I'm going to remember that. Now for the denominator cut points. Sometimes we don't have any denominator cut points, and it's pretty easy to spot when that is if there's no fraction in the problem. So denominator can't be 0. Well, that's a linear equation with a not equal. Isolate the x. So x can't be negative 1. Denominator cut points are always labeled with an open circle. For the solution cut points, you've got to look up here. But for the denominator cut points, it's always an open circle. Now let's draw a number line and label those two cut points. So what are the two cut points? Negative 2 and negative 1. Make sure you're putting them in the correct order on the number line. If you don't put them in correct numerical order, you're going to get the wrong answer. Which one would be further to the left, closer to the negative infinity? Negative 1 or negative 2? Would it be negative 2 here? And then -1. Open circle on -1, closed on -2, and let's test the interval. Since there was no factoring involved, no repeated factors, this thing's going to alternate. So let's see. What number do I usually test? 0. So where does 0 lie? Well, it doesn't lie between two negatives or between two positives. This is two negatives right here, between a negative and a positive. That's where we test 0. Hopefully it's clear why it's important that you know where that test point lies. Okay? Because if I get a true statement, then I'm going to shade this interval, cross out the others. If I get a false statement, I'm going to cross it out, say false, true, false. Okay? So testing 0. I'd have a 0 on top. 0 plus 1 is a 1. It's greater than or equal to 2. Well, 0 divided by 1 is 0. So what would y'all say about that? 0 is greater than or equal to 2. True or false? False? Yeah. So false. That's false. False. Let me get a darker pen. True. False. So my interval is bracket. When you're writing interval notation, the closed circle is a bracket, open circle is parentheses. So bracket -2, comma, -1, parentheses. Okay. Let's look at our answer choices very closely. They all sort of start blurring together. Is it A? Yeah, I'm thinking it's A. I'll write A in the blank. Any questions there? Hopefully you've done a lot of these cut point problems. If you've done the homework, you've done a lot of them. Okay? If you've gotten behind on the homework, then use this weekend to catch up on it. Now, 21, another inequality, but this is a absolute value inequality. Okay? That's not a 12 there. That's an absolute value. And I'll tell that. Absolute value of 2 minus x is greater than or equal to 9, 21. Well, there's no denominator cut points here because there are no fractions. So, let's start off by finding the solution cut points. We'll treat it or act as if it has an equal sign there. And if there'd been an equals 9, what are the only two numbers that can go inside these pink absolute value bars? What are the only two numbers that have absolute value equal to 9? Positive 9 and negative 9. So for these absolute values that you go equal positive, equal negative. 2 minus x equals 9. 2 minus x equals negative 9. And then it's a matter, what sort of equation do we have? Linear or quadratic? Well, two linears. There's no exponents there. So just isolate the x. And I'm going to do something that, I'm not sure if you want to do it or not. But what I would do is move this x over to the right rather than just subtracting the 2, because if you subtract the 2, you still have the negative in front. So then you got to divide by -1 to get that x by itself. So I think it might be easier in the long run if we do this. Follow my arrows. I'm moving the x over so it'll become just an x, not a negative x. And I'm moving the 9 over here, so I'm subtracting 9. So I would have 2 minus 9, negative 7 on the left, and an x on the right. Okay? Now, do the same thing over here. I'm going to move the x to the right, so it'll be just a positive x. And then add 9. Y'all add 9? So what are we getting? Is that going to be an 11? Moving the x over, we have x equals 11. Draw your number line. Oh wait, I didn't ask. These are solution cut points, so we got to look at the symbol. Are we going to have open or closed circles? Closed, okay. So now I'll draw the number line, plot those cut points. Here, it's pretty easy to plot the cut points. By that, I mean, most people aren't going to put the 11 before the negative 7. Since one number's negative and one's positive, negative 7 would be to the left of positive 11. And test an interval. Well, the number I usually use to test is 0. So where does 0 lie? Well, it's not between two negatives. It's also not between two positives. 0 is between a negative and a positive. So I'm testing 0. Sometimes it's not clear why I seem to think that it's important where that test point lies. And it does. It is very important. Because if I get a true statement when I test 0, then I shade this interval, cross out the others. If I get a false statement, I'm going to cross out negative 7 to 11, shade the other two. So testing 0. When I say test, I mean plug it into the original problem. We'd have absolute value. 2 minus 0 is just a 2. Is greater than or equal to 9. Well, let's see. The absolute value of 2 is 2. So 2 greater than or equal to 9. Is that true or false? That one's false. Okay? 2 is less than 9, not greater. So false, true, true. And we will write our answer in interval notation. When you were doing your homework with MyLab, you would type parentheses, negative infinity, comma, negative 7, bracket, union, bracket, brackets for closed circles, parentheses for open circles. Always use parentheses by infinity symbols. So bracket 11, comma, infinity. And this is what you would type in. But if you look at those answer choices, it's a little tricky in that those aren't listed there. Let's read all of these instructions. Okay? Where it says solve the inequality. When the solution set is written in interval notation, what is the first interval? Well, okay, here's the first one. That's the only one they list. They're only listing one interval here because they want all the answers to fit in one row like that. Okay, they're trying to use less paper. Okay, so negative infinity, which to negative 7. So answer choice C is the one. Okay? Why didn't I mention that part of the instructions on number 20? Well, on problem 20, there is only one interval in your answer. Okay? If you read through all those instructions, when the solution set is written in interval notation, what is the first interval in the solution? And then in case you don't know what they mean by first, the first interval is the one furthest to the left on the number line. if there's only one interval in the solution, choose that one. Okay, so on number 20, there was only one interval. You didn't write the union. But if there's two, they list only the first one. Why? What's the significance? Just to use less paper and less ink. The software I'm using is to make paper and pencil tests, and this decade they've been going through revising it to use as little ink and as little paper as possible. Okay? And then they still wind up with half pages blank every now and then. Okay? But I can't control that. So, number 22. Are y'all caught up with me? Any questions? It's another absolute value inequality. We have absolute value of negative 8x plus 9 is less than 6. Well, there's no denominator cut points here, so let's pretend there's an equal sign.
Is that 9 or 91?
Oh, no, that's a 9. It's absolute value of negative 8x plus 9. That's why I'm trying to draw the absolute value. Ooh, let's see. Let me do this. There, okay. Absolute values. Okay. Well, if on test you're not sure if something's absolute values, ask me. Okay, so pretend there's an equal sign. So the only two numbers that could be inside there to have absolute value equal to 6 are positive 6 and negative 6. So when you're solving these absolute value inequalities, that's when you go equal positive, equal negative. So now isolate the x. I'll subtract 9. So negative 8x equals 6 minus 9 is negative 3. And then divide both sides by negative 8 to get a positive 3 over 8. 1. And then over here, move the 9 over. So we have negative 8x equals negative 6 minus 9 is negative 15. Divide both sides by negative 8 to get x equal a positive 15 over 8. Those are solution cut points. So look at the symbol to decide between open and closed circles. It's going to be open because there's not an equal sign on there. Draw the number line. Oh, we have two fractions, but they're not too difficult to figure out which one goes to the left because they have the same denominator. The 3 over 8 would be further to the left than the 15 over 8. And now I'm going to test 0. Where does my test point lay? Is it here on the left, in the middle, or on the right? If I'm going to test 0, well, it's here on the left. 0's between a negative and a positive. I think it was when I was doing these 3 problems some years back that a student said, wait a minute, wait a minute, wait a minute. Why does 0 keep moving? Like on number 20, 0 was on the left. Oh, excuse me, on the right. On 21, 0 was in the middle. And then on 22, 0 was over here on the left. Well, 0's not really moving. It's the test points that are changing, and the way you locate where is 0. 0's between a negative and a positive. So it's in this interval. It's not in the middle. It's not between two positive numbers. It's not on the right, because it's not between two positive numbers. So that's why if someone asks you at the end of the semester, what did you get out of Mr. Precella's 6 hours of algebra a week? You can say, I can locate 0 on the real number line. And that is a joke, okay? Hopefully you got more than that. But yeah, being able to locate where the heck the 0 is actually pretty significant. So I'm plugging a 0 in for x. Absolute value. -8 times 0 is 0, plus 9 is 9. That's not 191. That's absolute value of 9, which is 9. So we have the statement, 9 is less than 6. True or false? False. So false, true, false. So our interval would be parentheses, 3/8, comma, 15/8 with parentheses around them because they're both open circles there. Okay. Let me see, which one is it? Is it D? Yeah, answer choice D. Okay. Any questions there? Finally through with those cut points. There's a lot of cut points. I think it's 17 through 22. Okay. Now, problems 23 and 24, little formulas that you gotta have memorized at least for a short while on your test day so you can get your test and write it down. The distance formula and the midpoint formula. Let me go ahead and state the distance formula. Well, let me write down problem 23, then I'll write it down. So we're told find the distance. Oh, all of my pins are going dead. To be, I made over 300 videos with these pins. I guess I shouldn't complain about them. Okay. Parentheses 6, comma, -1, 4, -7. The distance formula. Let me write it down. Basically going through the Pythagorean theorem, calculating a squared, or a and b, and then a squared plus b squared, c squared. It's second x minus first x squared plus second y minus first y squared, all under that square root. I'm going to plug in here, and you know what I need to do? Let me go ahead and label those ordered pairs. Remember, ordered pairs are x, y. The things I've written in green here, that's not an exponent. All that's a subscript, and it's just saying the second x and the first x. So here's the first x, first y, second x, second y. Remember, ordered pairs are always x, y. Don't label it x1, x2. That's a common mistake. But ordered pairs aren't xx. They're xy. So now, plug in. Watch out for these negatives. Okay, so I'm now plugging in second x minus first x. That's the 6. Second y, here go the negatives. We have a -7 for the second y. This red minus is from the formula. Now y1 is a -1. So we have a red minus from the formula, a green negative, so that's becoming a +1. Okay. And up there on the projector, the colors don't show, but they show better on the video. Okay, maybe that green looks like black, but it's green. Okay, so let's simplify from here. The 4 minus 6 is -2. So we have -2 squared plus -7 plus 1 is -6. So let me see. -2 times -2, that's a 4. Plus -6 times -6, 36. So we're getting a 40 under that square root. Yeah, oops, covering up the problem. So we have square root of 40, which we need to simplify. We know we're not finished because it's not listed as an option. Okay. Square root of 40. Well, some of you have those little Casio calculators. You just punch it in, they'll give it to you. Others, well, we'll do it by hand. What perfect square divides evenly into 40? Well, 4 times 10 give us 40. The square root of 4 is a 2. The square root of 10 we can't simplify. We leave it as square root of 10. So 2 square root of 10. Look carefully. It's another D, isn't it? Ooh. The distance formula. Okay. There's 3 formulas you have to have memorized for this first test. The quadratic formula, distance formula, and this next one, midpoint formula. The midpoint formula is an easier formula. To find a number right between 2 given numbers, if someone said state the midpoint formula, you could just say this. Average the 2 x's and then average the 2 x's. Average the 2 x's, average the 2 y's. Now, if you don't know what I mean by average, if you want to actually write it as a formula, to average something, you add them together and divide. So if I want to average the 2 x's, I add them up and divide. To average the 2 y's, I add them up and divide. Now let's see. Let me go ahead and label these ordered pairs. First, and y'all see that? That's first x, first y. Maybe I should recopy the points. Here they are. -3, -2, 4, -9. First x, first y, second x, second y. So now average the 2 x's. Add them up. x1 is -3. x2 is 4. For the y's, y1 is -2. y2 -9. And I think we're going to wind up with some fractions here. It'd be better if you look at the answer choices. Let's see, -3 plus 4 is a 1. So 1/2. -2 plus -9, -11. So 1/2, -11. That looks like answer choice B. Okay. Any questions on that? So find that midpoint. You just add the x's, divide by 2, add the y's, divide by 2. When you're typing in the answers on MyLab, it's a bit more tedious. You've got to put those parentheses. Remember, it's going to count it wrong. But here, it's just multiple choice. You get the 1/2 and the negative 11 over 2, whether you write the parentheses or not. They're written there in your answer choices. Now, I might need to zoom in on this one. Here, just graph the equation by plotting points. It's the last step on the test. And I'm just going to make an XY table. Now, I'm going to do it without any fractions, okay, or decimals. If you want it, like if you plug a 0 in for x, 0 plus 3 is 3. The square root of 3, if you have your calculator, you can punch that in. It'll give you a decimal value. I think I'm just going to, what about a 1? If I put a 1 in there, is it going to give me a decimal or not? If I put a 1 in for x, I'm just getting a 2, right? The square root of 1 plus 3. 1 plus 3 is 4. The square root of 4 is 2. Okay. So I think I'm going to get a couple of them before I look. Maybe just knowing that point is enough to decide which one it is. But let's just find another number to plug in. Well, if I put a 2 in for x, that's going to give me a decimal. A 3 would give me a decimal, square root of 6. A 4 would give me square root of 7, another decimal. A 5, oh wow, are there any that aren't going to give me decimals? What if I put a 6 in? If I put a 6 in for x, what would that give me for y? Is it going to be a decimal? Is it a 3? If I plug a 6 in for x, 6 plus 3 is 9. The square root of 9 is 3. I think having those 2 points, you can decide which graph has those points. Right 1 up 2. Answer choice A is definitely not correct. It doesn't have the point right 1 up 2. What about B? Right 1 up 2? Nah. C? Oh, it better be D. Let me see. Right 1 up 2? It looks like that one. Let's just be careful. Let's be certain. Make sure that other point, 6, 3 is on there. Right 6 up 3. 1, 2, 3. Yeah. Oh. So it is graph D. Nothing real advanced. You're just plugging in numbers. But you got to be careful. You can't just plug in anything. Like I couldn't plug in a negative 4. Because if I plugged in a negative 4 for x, that's going to give me an imaginary number. And on these graphs, you only have real numbers. No imaginary numbers. No i's. There are no i's on the x-axis or the y-axis. Only real numbers. Okay? Any questions there? Well, that does it. I've done the whole review sheet. Answers are on the last page. The letter answers, if you don't want to actually look through the videos to see the answers. But this is Mr. Precella. Thanks for listening or watching.